it's also been a little while since we looked at inverse trig, and inverse trig is necessary to do integrals that involve the derivatives of inverse trig functions, at least at this point. Okay. If I look at this and don't recognize that that's the derivative of an inverse trig function, I'm going to spend an awfully long time trying to figure out some legitimate algebra that I could do to write this in a way so that I could use a rule. And I'm going to fail. Okay? We don't have the tools to do this unless we recognize that that's the derivative of arctan. Okay. So, remember I've said I don't care whether you're familiar with the derivatives of the inverse hyperbolic trig functions. In fact, I won't give you any credit for having those memorized because that's, in my opinion, just trivia. Now, if you're using them on a regular basis, they could become useful, but we're not going to be using them on a regular basis. But we do use the regular inverse trig fairly often throughout this course, next semester, the following semester. So, super important to remember that the derivative of arcsine of x is 1 over root 1 minus x squared. A little bit less important to remember that the derivative of arc cosine of x is negative 1 over root 1 minus x squared, at least for the purposes of integration, simply because if I had to integrate this, I could just factor out the negative and then I'd have this and I could use arcsine. So these derivatives are so similar that if you know one of them, you can use that one for your integration problems. Now, for the purposes of taking the derivative, of course, you should know both of them, but we also know how to derive those. Okay. Also important to remember that the derivative of arctan, we just saw that, is 1 over 1 plus x squared. And the derivative of arcsecant is 1 over x times root x squared minus 1. So the subtraction problem under the radical is the reverse of what it is for arcsine, and there's an extra x out here. All of these are things that we would find very difficult to integrate without being able to say, oh, I know an antiderivative. That's going to be this inverse trig function. Okay. Not super important to have memorized the formulas for the derivative of arc cotangent and arc cosecant. You should know how to derive them for all 6, but it turns out there's a similar relationship to what we have here, that the derivative of arc cotangent is just the opposite of this, and the derivative of arc cosecant is just the opposite of this. So if you know these 3, those are the 3 that will allow you to integrate expressions that involve those formulas. Okay. So here, I would just say, oh, well, that's arctan of x evaluated between 0 and negative 1. So that's arctan of 0 minus arctan of negative 1. Now, I do expect you to simplify your inverse trig functions if they work out nice. By nice, I mean that if the angle in question, because remember the output from an inverse trig function is an angle, if that angle is a quadrantal angle, or if it's an angle with reference angle pi over 6, pi over 4, or pi over 3, you should be able to evaluate it. So I'm saying zeros and negative 1s. I'm thinking these are probably nice ones. Okay. So I'm just going to call that theta 1, and I'll call this theta 2. Okay. Now what I know about theta 1 is that tangent of theta 1 must equal 0. That's the value of tangent. I'm looking for the angle. Okay. Now, infinitely many angles satisfy that, but remember with inverse tangent, my angle has to be in the interval from negative pi over 2 to positive pi over 2. Now, there is one and only one angle in that interval whose tangent is 0, and that angle is 0. Okay. So, this angle is just 0. Let's work out this one. Tangent of theta 2 has to be negative 1. Okay. And theta 2 has to be in the interval from negative pi over 2 to pi over 2. Now that interval corresponds to quadrants 1 and 4. If tangent is negative, I know I'm talking about quadrant 4. So I'm talking about a negative acute angle. So if that's my theta 2, alpha would just be the opposite of that, because alpha, the reference angle, is always just a positive acute angle. And what I know is that tangent of alpha would be the absolute value of -1, which is just 1. Well, what acute angle has a tangent of 1? That, of course, is pi over 4. And I see that because if I draw my 45, 45, 90 triangle, where 45 degrees is just pi over 4 radians, remember that's an isosceles triangle. So the opposite and adjacent are exactly the same. Okay. So if my reference angle is pi over 4, but theta 2 was a negative angle, it's just negative pi over 4. So arctan of 0 is 0. I'm subtracting arctan of -1, which is negative pi over 4. That becomes plus pi over 4 is my answer to that. Okay, excellent. I'm going to put another one up on the board. I've sort of given away that it's going to involve inverse trig, but you can deal with that. Let's try integrating from 0 to 1/2 5 over the square root of 1 minus x squared dx. And I'm going to end this video here. I'm going to suggest that before you turn on the next one to work through that together, that you try working it through on your own. I will start the next video by giving away the answer so that if you get it right and felt comfortable with it, you can just move on. But if you want to work through it together and review the process, we can certainly do that.